Okay, let's stop. Anyone who have a comment about the video? Maybe some of you wants to comment or have an opinion, please.
Yeah, sir.
Yes, please, Rehan.
Yeah, so what I observed from the video is that it got a load on at the very end of a slinky that is connected to a, maybe we can call it an oscillator or a frequency generator. So at first, at some frequency with with input magnitude, it will bounce the way uh, synchronized to the exact input of the system. And as the frequency goes higher, the magnitude will increasing. And when there is at certain point that the magnitude, the frequency make the output of the system is out of sync. And uh, probably it's because of the dampening. I'm not very sure, but that's what I observed, sir.
Okay, thank you very much, Savero. Yeah, okay. Is there any other opinion, please? I haven't decided which is correct or not. I want to explore the opinion from you. Any other opinion, please?
Yes, sir.
Who are you?
Daniel.
Oh, Daniel. Okay. I'm sorry. Okay, please, Daniel.
Yeah, so from the video, I think with very low frequency, we can determine, roughly determine the magnitude and the phase of the system with our eyes. But with higher frequency, it's becoming harder and harder to determine the magnitude more accurately. And then with higher magnitude, the system becomes more out of phase, even though it doesn't have more than one input. So I think in higher frequencies, the system gets more affected by the previous inputs than in lower frequencies.
Okay. Thank you, Daniel
Yes.
Siporo. Appreciate. Okay. Is there any other opinion, please? Haha. Yeah. Any other opinion? Don't be shy. Okay. Come on, guys. Come on. Should I call? Maybe Adrian. I need your voice.
Hello, sir.
Yeah, hello. Are you okay?
Yes, I'm fine.
Yeah, okay. Please give your opinion about the video. Hello, Adrian. Are you there? Hello. Hello, Adrian. Budiharsono ya. Budiharsono.
Hello,
Yeah.
sir.
Give your opinion, please.
Yeah, I think the frequency response the phase is more in increasing the frequency. The phase is out of phase, sir.
As the frequency increase, the phase is out of phase. You mean like that?
Yes. Yes, sir.
What is the meaning of out of phase?
I mean, it is going to make
What in terms of input and output phase, what is kind of relationship? Hello.
hello, sir.
Yeah. Do you have any trouble about the internet connection?
Yes, sir. Sorry,
Oh,
sir.
yes. Oh, okay. Okay. I understand. Okay. Maybe you can try later. Okay. I need a comment from Bobby Yurismono.
Yes, sir.
Yes, please.
That's the I have a comment. That's the video like shows like angular frequency. Is it? I don't know. Like I don't really get it, but like because I'm not like I'm not used to watch a video with a what is it subtitles, so I didn't hear like I cannot like just from seeing it I didn't get any of it. But is it connected to an angular frequency or? I don't really know. I just have that question, sir.
Okay, yeah. It is my purpose that yeah, actually the text is a bonus for you. Actually, the thing that I want to know is you really watch the phenomena from the video itself. Actually, the video has a voice, yes.
Okay,
But I need how you interpret this phenomena. Yeah, it's up yours understanding. Yeah, no worry.
Yeah. Okay. I guess like as you like put a like higher voltage on it, is it like changing the way the or is it the disc turn around based on the like the the strength of the strings? I guess.
Okay.
Yeah. I think that's my comment there.
Okay. Thank you. But anyway, maybe I have to clarify a bit more. Do you agree that this kind of the coil and the movement of the CD is a system?
In a way, I think so, sir, because there is an input and output of it.
What is the input?
I think the voltages that the guy is like changing, not the voltages. I don't know. Like he changes a lot of things. I think it's the load or the frequency or something, and then the output will be like the movement of the disc. I think so, sir. I don't know.
Okay, no problem. So in your opinion, the input is
the one that the guy is changing, sir.
The way the guy is changing,
I don't really know.
What is the impact about the rotation of the rotor?
Oh, it can go out of phase, I guess.
Eventually. In terms of rate of the rotor.
Oh yeah, it can increase or decrease the.
Okay, it can increase and decrease, right?
Yes, yes, sir.
Okay. So I want to make some, how to say, specialization, but wait a moment. Okay. Should I? Okay, this one, and then I would like to notate this one. Can you see, Bobby?
Yes, sir.
Yes, actually, if we locate it, we discriminate on this only in this system without this one.
Yeah.
Can you determine which one the input?
I think the cable with the white thingy on top of the red box, that's the input.
This is the input. What then? Where is the output?
The output is the spring, I think, the coil, I guess.
The coil? This one?
Yeah, I think. I don't know.
Yeah, no,
Oh,
no.
Yeah, I think the input is the one on top, sir. The one on top of the red box, the white.
This one?
Yeah, I think, yeah.
What kind of input here?
It's what is it, like rotating based on the like electricity, I guess. I don't know.
Okay, rotating. Okay, I want to make it clear that this is a rotating. So can we draw the signal that are rotating?
I guess so.
Yeah.
Yeah.
Do you agree about this? This is the input signal?
Yes. Sir.
Okay.
It's sinusoidal. Yeah.
Okay, good. Yeah, everyone. So in this case, the input signal is kind like that. And then the system is here. Yeah, the system is here, and it consists of like a spring. Yeah, and what's more, this is like a mesh. Yeah, like a mesh. Yeah, and where is the output?
Is it the disk, sir? I don't know. Is it the wait? The rotation of the spring is, or
the rotation of the spring.
I don't know, sir.
It is easy, right? Which one? Which one? I think I believe that you all know, but maybe you cannot how to say describe. Okay.
Yeah.
In which position we can get the output in A, B, C? Which one?
C, sir.
Or... C. Perfect. Yeah. Yes, we can get the output from C positions. What kind of output here?
Rotation.
Rotation. Rotation of what?
Of the disk. Is it? Wait. Or the like. I don't know, sir.
You don't know. Okay.
May I, sir?
Yeah.
I think the output is the mass, which is the disk, and the output is in form of an oscillation, sir. So it's going up and down.
Okay.
That's the word, sir, oscillation.
Yes. I believe that you know, Bobby. But maybe it's different. It's hard to express. Thank you, Safero. That's the point that I want to point out. So, Bobby, you already you understood, right?
Yeah, sir.
Okay,
you,
good. So, the output, if I write the YT, it's gonna be it's kind of like this. Yeah, it's kind of like this. Okay. So after you identify which is the input, which is the output, and which is the system, so I want to characterize what is the changing in the input. Maybe I need ask the guys. Nadia Mayesa, are you there? Nadia?
Yes, sir. Hello.
Yes, yes. Okay, good. You have seen the video, right?
Yes, sir.
Completely? No? Or just enter the
It
class?
was a bit lagging in my part, but
Oh, okay. But anyway, can you mention what changing in the input signal?
the change in the input signal.
Yeah.
The frequency and the voltage, sir. Maybe.
Frequency and the voltage.
Yes.
Okay. Actually, that's correct. The voltage is coming from here, right?
Yeah, I mean the voltage makes the frequency change. So.
Okay, good. But if we discriminate on this system, the changing is only what?
The frequency.
Frequency per phase. You get it? Agree?
Yes, sir.
Okay. You remember? You can see from the video when the voltage, of course, the voltage is higher, and then the frequency, the rotating is the rate of the rotating increasing, right?
Mm-hmm.
And then what's happened to the output when we increase the frequency?
Well, when the frequency is increased, the I think the phase changes.
Phase changes. Okay. Everybody agree? Phase changes. Anybody not agree? Please raise your hand. Maybe give notice.
Or maybe from what I remember, if the frequency is low, it stays the same. But if the frequency is higher, the phase changes until it's out of sync.
Okay. First is phase changes. Any another parameter that change?
Maybe the magnitude, sir.
Magnitude, perfect. You can see from the video that when the frequency changes, the oscillation, yeah, the peak and the bottom is changing. Maybe from the low frequency, the changing is only maybe a certain level, but when we increase the magnitude also changes. And when we increase more the frequency, however, the magnitude is decreasing, right? Do you agree?
Yes, sir.
Yes, okay. In this phenomena, we can conclude that the phase of the output signal and the magnitude of the output signal is a function of input frequency. Is that correct? Everybody agree?
I would say yes, sir.
Yes. How about the frequency? The frequency of oscillations. Is that changed? Maybe I will ask to the Goldie. Goldie, are you there, Goldie?
Yes, sir.
Yes. What is your opinion about the frequency of the output signal?
The frequency from the output signal is
respect to the frequency input signal.
Based on the structure of the coil, maybe.
Yeah. Sir? Is that change or not? The question is that change or not?
It changed.
Change. Yeah. Okay. So, in your opinion, the frequency of input signal is not equal. It means that it's changed.
Yes.
Okay. Everybody agree about the Goldie's opinion?
Yes, sir.
Yes. Yes, no questions? Why or something?
Sir, why?
Yes. What is your question or opinion, Daniel?
I'm not sure why it would be different.
You not sure what about what?
I'm not sure why the frequency of the input and output would be different.
Okay, so your opinion is
It's equal.
equal. Okay. Siboro has an opinion that this frequency should be equal. Oh, it's a good to say a different perspective, right? It should be equal. Okay, any other opinion?
Sir, I
Yeah.
think well, I'm not really sure if it's
Yeah.
if
No
we
problem.
try to look it at the signal and system subject, but based on what I learned in physics, that the slinky or the coils, it has some function that changes, yeah, the magnitude, and I'm not quite sure about the frequency, but there is some. Well, if we observe from what happened in the video, is that at higher frequency, uh, we cannot really see the frequency that would be equal to the input. So I'm not sure, but yeah, that's my point of view.
Okay. So, in another words, means that the Safero has a difficulty to see the system about the changing frequency given from different input output. Yeah. Okay. Anyway, later we will prove. Maybe which is the gang of different frequency, which is the gang is equal frequency, or which is the gang is confused. Okay, anyway, thank you very much for your opinion. Appreciate. Okay, anyway. Wait a moment, and then okay. Which prefer? Do you want to continue the video for the explanations, or you need from my explanations?
I like your opinion, sir.
No. About not opinion. My explanation actually.
Yeah, I mean your explanation.
Yeah, your explanation, sir.
I thought you are interested in the video, but I'm very like if you want to interested in the video, so I can take a nap for a while. Okay. Anyway. Okay. Okay. Anyway, no problem. Stop screen and then let's. See, yeah. Okay. So I have to make a bit summary about your yes. Yeah, your understanding about that. Yeah, yeah. Actually, when we are talking about the LTE system, yeah, system in frequency domain. Actually, yes, this is, yeah, we have an input here, X. This is the system, and this is the output. And you realize that the when you realize that the magnitude of y as well as the phase of y is a function of, yeah, is a function of input frequency, right? Until that you can understand about this one. Actually, why we write the omega, you remember the omega is 2 pi frequency, right? Okay, that's why you can directly see that the magnitude of y is affected by the input frequency of the signal. Yeah, so it's more clear that mathematically we can write things like this. Yeah, yeah, yeah. It's changing. This component is changing the magnitude and the phase of the output, yeah, the output signal. So also, if we have something, wait a moment. So, because the magnitude changing, in this case, we can write if the input is A minus what? A minus j omega t, and this is the input signal represent in frequency domain. Why? This is a yeah, we can represent this is a signal in time domain, but also we can say this is the signal in frequency domain. Why? We can say is in time domain. You can see here why this is a in time domain, because you can see time domain because the t. Okay. How about the frequency domain? Yeah, it's simply because we can a minus j 2 pi f t. You see now that this is also works in frequency domain. Okay, everybody agree, yeah? Everybody agree. Okay, and then because you can see here that the given any function, yeah, any function of the system, so we can say that the output signal will be let's say maybe m multiplied by a minus j2 pi ft plus the phase. Phase, the m is a magnitude. Actually, please look at this one. Look at this this part. This part. Actually, this part is equal to this one. So if this is input signal, yeah. This is the input signal, yeah. The input, no. I need to write in a frequency domain. Yeah. So omega. So you can see here, the output signal is a version of input signal which change the magnitude and change the phase. Maybe some of you asking, the changing the phase is located here. Yeah, I put on the power mode, and you remember that like a polar. Let's say this is z. This is the variable z. This is a complex number. Complex number. You remember that complex number. This is the A is magnitude. A is something that might be T plus omega. Please see. This is the magnitude. And this is the phase, right? What happens if phase is 0? The C is 0. Which one? Something like that. Actually, this is let's say only like this. That actually this is only real part. Yeah, real part. Yeah, because we can easily yeah, this is a complex number still, but the phase is 0. Phase is 0. It means that if you remember, its position is like this. Yeah, this is that. You remember? Yeah. Okay. Until this point, everybody agree? Or some of you have any question? Has any question?
Agree, sir.
Clear, yeah? Also, from this relationship, from this relationship, we can answer. We already answered about the changing the frequency. You see, this frequency doesn't change. You see here, this is still F. Also, this is still F. Doesn't change at all. So the frequency input and the frequency output doesn't change. And you can imagine, or how to say, you can take a practice from maybe the MP3, the MP3, when you play music, and then you open the player, open the equalizer. You remember? Yeah, equalizer. Yeah. When you changes then in the equalizer, there is several how to say instrument to to how to say, to adjust the power. For example, there is a bass, there is a voice, there is a percussions with different frequency, right? So in this case, for example, you increase the volume of the bass, and you still hear the same song, right? So the song doesn't change. Maybe also you can maybe adjust the volume of the voice. Maybe if you want to karaoke, so the voice from the singer, you how to say, ditekan, apa sih namanya, diredam begitu, dihilangkan bagian voice-nya sehingga kalian bisa karaokean. Dan ketika meredam itu suara musiknya tetap sama kan? Suara musiknya tetap sama, tidak lantas berubah, frekuensinya tetap enak. Nah, itu bukti nyata. That's the physical proof, phenomenal proof. Then the frequency of input signal doesn't change the frequency of the output signal. Okay, that's the point. Okay, so back to this expression. Yeah, back to the expressions. Actually, the magnitude and the phase. The next question is how to compute. How to compute its magnitude. How to compute the changing of the phase. How to compute. How to compute. That's the thing that we want to learn. And what is the meaning? Actually, what is the magnitude come from? This phase is whose the phase? The phase is belong to what? The magnitude is belong to what? So so my question is, the magnitude is belong to input or system? Anybody can answer?
I think it's system, sir.
System. Okay, perfect. Yeah, this magnitude representing the system. How about the phase?
I think,
Sir, I think it is belong to the input.
The input. Why?
I think because in the input function there is the omega, so it will, yeah, it will.
It changed the phase,
yeah,
right?
Change the phase.
Oh, okay.
I think because of the output can be delayed or advanced in time and also in frequency, right?
Mm.
So the phase represents the shift.
Mm.
Like, for example, if you have a voltage and current, the current can be advanced in relation to the voltage, or the voltage can be advanced in relation to the current. because the output can have a lag.
Yeah, yeah. Wait a moment. I have to. Actually, I agree with some of you that the phase is belong to the input. But the right answer is phase is belong to the system. But I a bit agree with the comment that the phase is belong to the input, actually coming from the changing the frequency of the input, also changing the phase, right? But in this case, because the input is doesn't change in this case, so the phase and the magnitude is belong to the system. Belong to the system. In this case, yeah, you can see here the magnitude of the input is 1. The frequency of the input is f, just f. And at the output, you can see here the frequency is still f. And the phase of the input is 0. Yeah, the phase, yeah, right? But in here, yeah, still the phase coming, actually this phase component coming from the system. And this is, if you mathematically calculate, this is one actually from here, the input. And the M itself, and the zero is coming from the input. Yeah. Yeah, as you can see here, and this is a 0. So in this case, yeah, it's clear. The magnitude here is coming from the system. The phase is coming from the system. In this case, yeah, something like that. Is there any question, any comment, please?
Sir, I think, yeah, I agree with you that the phases belongs to the system, because I think the phase changes because of the mass that is attached to this link key. I don't know.
Yeah. Yeah, in our scenario, in our example, yes. It's like a damper. Yeah. Okay, any other question? Any other question? So I have to make a bit clear the screen. So as you can see from this example, yeah, given the input A minus j omega t, this is the xt, and the output become a magnitude a g omega t plus phase Also, we can say like M A powered by phase. A minus J omega T. Is that correct? Correct, yeah? So in this case, if we write again, this is actually, this is the input, right? And this is actually something, yeah, something, you know, something, so something variable, so we can write like this. Is it okay? Yeah, okay. So you can see here that the output version of the LTE system in frequency domain is just a multiplication with some variable. Is it correct? So this lambda, this variable, we can say as a eigen value, and the xt with whatever in here or in here, we can say is an eigenfunction. Eigenfunction. Yeah. Actually, this naming is nothing. Ya, again, this naming is nothing. Penamaan ini hanya nama lah, gitu ya, hanya nama. Tapi the point is, this eigenvalue representing the system and the eigenfunction representing the input. Yeah, something like that. So from this point, if we give input any function, the output is just a multiplications between the input xt and the system. But you should remember this simple multiplication in frequency domain. So this is the S omega in frequency domain. Okay, you got it? Any question? And we just prove, or we just conclude that the interaction between output, the output is a result of interaction between the input and the system. And you remember, in time domain, the operation should be in convolution. Is correct? In time domain, if we compute in time domain, the operation between input and the system, it should be convolutions, which is a complicated, you know, time consuming and make you confused. But if we compute in frequency domain, you see, this is y omega is just multiplication, simple multiplication. You see, this is a simple multiplication between input and the system. That's the point. So you see, if you compute input and the system in time domain, you should compute in convolutions. But in the frequency domain, you only compute in simple multiplications. Any questions?
Not yet, sir.
Not yet. Good. So that's why transforming again, when we have usually if we have a signal in time domain, to convert to the frequency domain, we need a Fourier transform. You remember, yeah? In engineering mathematics, you already know how to compute from time domain signal to the frequency domain signal. Yeah, maybe some of our class later, we will discuss about the Fourier transformation. But I stress you, to to open by yourself how to transform from time domain to the frequency domain. Yeah, some of the meetings, some of our discussion later, we will talk about the Fourier transformations. But yeah, again, please, I encourage you to open your book, your literature, your notes, how to transform from the time domain to the frequency domain. Okay. Okay. After I talk a lot, is it now time is yours for exercise? Okay, I have a system. A system. System. The system is being like this. Plus 2yt and the input as well. We have an input, right? We have an input, we have an output, yeah? Yeah. And the input signal, are follow. First is I minus t. Number 2, a t. 3, a g t. Yes, this is g. Number 4 is cos t. Number 5 is ut. You remember this is the first differential, yeah? First differential, yeah? So it's mean that why the accent, this is accent, yeah? It's mean that first differential. So the question is, first question, question one is determine if each of the following function, I mean the input function, yeah, input function, yeah, not the following input functions is an eigen function of the system. The system, this one, yeah, this one. And second two, if yes, find the eigenvalue. Okay, you have 30 minutes, yeah? 30 minutes. Okay, start from now. You conduct by conduct by the conduct in your group is better. Okay, so I need to divide you into only 2 groups. Okay, so I need to chat. This is chat. So I send you the screenshot of the screen in chat box. Please check it. And then I would like to divide you, or divide and conquer. Okay, so break room into 2 groups. Okay, you have 30 minutes. So at 11:45, we get back to the main session. Enjoy.